Hello everybody, my name is Thao and I'm a chemistry major at Berkeley, Minnesota. And today I'm talking about polymer electrolyte membrane fuel cell technology, which is PEMFC for short. The point of PEMFC is that it's considered the most promising conversion system for electric cars, and so that society these days are trying towards a green way of transportation or getting everything. And the reasons why is for a better tomorrow. As developing countries are becoming global power, for example, China and India, it is increasingly more important to find a greener way to live for as a human race because if everybody is losing the earth, then eventually the future will outrun us. So finding a greener way to live will be the most effective way to live. Some people may say that fuel cell research is not worth the cost and it's not going anywhere. And they assume that's that because there's no news coverage of it. But then recently, a car has made the headlines, which is the Toyota's Miura. The Toyota's Miura is a new car that runs on hydrogen fuel cell technology, and it is developed by Toyota. Miura means in Japanese the future, and then what it basically does is that it runs on hydrogen fuel cell technology. As you can see here, this is the hydrogen tank with the best. My point is that if you put more investment into the fuel cell technology, it is possible to make a Ford Miura or the next fuel cell technology car, especially made in the U.S. It's not just shipped in from out of state, out of country. And then with funding, you're able to fund some kind of research, and this is an example of research that you couldn't have funded. This is a research done in Korea by Yong-Gap Chung and Chin Sung Kim. The research that they did was they tested the performance of a polymer electrolyte membrane fuel cell with thin film catalyst electrodes. And then what is PEMFC? Because I've been talking about it a lot, and I'm pretty sure most of you guys don't know about it. PEMFC consists of two main components, which is the membrane electrode assembly (MEA) and the polymer electrolyte membrane (PEM). The MEA is the structure of how the membrane and the electrodes are arranged, and the PEM is considered to be the separator between the anodic and the cathodic component. As you can see here in these diagrams, this shows you how it is rearranged. As you can see here, this is the few hydrogen from here and the oxygen from outside, and these two interact, and then air and water vapor comes out, and this is where the proton exchange membrane is located, and this is where the membrane electrode assembly is located. And this is a realistic version of what it will look like at the end. As you can see here, this is layers after layers after layers of the MEA and PEM put together to make a fuel cell. And back to the research, MEAs is fabricated by different catalyst layer preparation procedure, and they are evaluated based on their cell performance. This research is specifically comparing the conventional MEAs to thin film MEAs. And then because of the time limit, I will not be talking about the methods because the method will take over 30 minutes. And then if you look at the handouts on page 175, you will see the methods. But then what it basically does is that they manufacture a catalyst layer and carbon paper and hot press them together onto the membrane, and that's how you guys make the MEA fabrication. There are two types of MEA made, which are the conventional MEA and the thin film MEA. As you can see here, the conventional MEA looks like this, and the thin film MEA looks like this. The difference between them is that for the conventional they use carbon paper, and then for the thin film they use gas diffusion vacuum layer. So this is the first result that we made. This result is comparing high cholesterol and low cholesterol, as you can see with triangle and square, and they're also comparing low temperature to high temperature with the circles and triangles. And this result is comparing the cell voltage density against this comparing the commercial MEA with the thin film MEA. As you can see here, there's a difference at 0.6 voltage. As you can see here with the dark circles and the light circles, which are comparing the best MEA with the best commercial MEA with the thin film MEA. As you can see here, there's a difference at 0.6. And this is because the photon penetration gases accessibility have been a factor in determining the active region of the layer. As the current density increases, the active region narrows, which is using, if you compare the circle and the triangle, you'll see that. But then the MEA at 40% platinum catalyst, which is represented by the square, have more density, so it will have a higher performance than the triangle, which is at 20%. And then the next result that we're going to look at is talking about the comparison of the cell voltage with them using 4-stack and 2-stack. As you can see here, the 4-stack tends to be better than the 2-stack because the 4-stack will produce will have more electrons going through it. And then to conclude this, the conventional MEA has 350 milliamps per square centimeter, as you can see in figure 6. And the thin film at its best is 650 milliamps square centimeter, which you can see at figure 5. And then for a large electro single cell, it will perform at 400 milliamps per centimeter square at 0.6 voltage. The conclusion is that the thin film MEA can replace the conventional MEA. And then, as the importance of the research that this shows that there is room for improvement. That's why funding is needed. As you can see here, this was made in 2000, or around 2000, so there has been way more technology done, and which actually will actually make this technology actually be useful in today's world. As you can see in Toyota's Mira, they have actually done a lot of research, and they have actually made those research into developing an actual car that will be coming out in 2015. And then if Ford was able to fund the development of fuel cell car, it'd be possible that Ford would be the first company in America to produce America's first fuel cell car. Any questions?